help out a little bit more. First of all, this is a protractor. Here's a tool that you probably haven't used too much, but it's going to help us here. I want you to focus on the inner. There's the outer circle and the inner circle, the inner measurements, which is here 0, 10, 20. But it depends on which side of If these two lines that you see at the bottom, the purple and the red, were here, for example, right? And we would move that arrow that way, then we would use the outer circle there, right? But since we're starting on the right side, and obviously you know that that is 0 degrees, let me just try to put them on top of each other. No, I can't. All right. So imagine those two lines on top of each other. If I asked you to rotate and think about what the angle is the measure of amount this particular line is rotating around this fixed point. So we're going to rotate around that guy. So let me take the purple line. So if I told you, let me bring the protractor a little bit lower. No. Okay. Paste again. If I were to bring the protractor right there, perfect. Right, so now that's 0 degrees. So if you asked me to move that purple line, right, and say move that 20 degrees. Now this space between the two lines, right, just created a 20-degree angle. If you said let's rotate a little bit more, let's say, oops, right, again, we're rotating against that fixed point, which is here, right? So rotating that, I don't know, 60 degrees. We'll stop right there. 90 degrees, and we already know that it's a right angle. So that angle is a 90-degree angle, and we use this little symbol here to say that, hey, that's 90-degree angle. Anything less than a 90 degree is called an acute. So all these, anything less than 90, all these angles are acute. If it's greater than 90, let's say this angle right here, I don't know, 123, for example, this angle right here. Looks like 120, 122, 123. So this angle here is 123 degrees, and it's called an obtuse angle. Okay, so we talked about that today, and let me just show you. If I rotate and rotate and rotate and keep going and going and going, this will create an 180-degree angle right here. This measurement here is 180 degrees. Okay, so I hope that helps a little bit. Now, why am I telling you this? Because some of the problems that you did today, or we're trying to do today, right, involved a 90-degree angle. Let me just make it properly. So 90-degree angle. Right. And a 90-degree, sorry. Right, so that might not be perfect, but imagine this was a 90-degree angle. So we know this is 90 degrees. But if somebody came over here and said, I want to split that into two different angles, split right here. Right, you could take your protractor, measure it, right, measure it, and say, let's say this was, I don't know, looks like 25 degrees, and they ask you to find this missing angle. Well, you know that those two, right, the sum of those two, you know that the total is 90, so this angle right here that we don't know would be 20 minus 25, which is 65. And these two angles complement each other, right, and hence the name, complementary angles. Two angles that added up equals to 90 degrees. So no matter what you call this, even if you call this angle A, give it a name, and this is angle B, the one thing you know for sure is that given that they're 9 degrees, this is a 9-degree angle that was split into two, you can say that A plus B, angle A plus angle B equals 90 degrees. And that knowing that helps you set up the equations that we worked on today. Likewise, let me make this take that. Okay, so imagine I take this and rotate it around. That's 90, 110, 120, 130, 140, 150, 160, 170, 180. Now this forms 180. As it is 180 degrees. But, like I said, what if you came over here and split this into two parts? I don't know. Right, and call this 3x, and let's call this x. And you wanted to find the value of the angles, well, and you had to set up equation. Well, the one thing you would know, you know that this angle, which is called 3x at the moment, right? And this angle, which is called x at the moment, you know that if I add those two, they equal 180. So knowing that these are supplementary, knowing that they add up to 180 helps you set up the equation. We had another case where it was, let me erase everything, vertical angles. Clear objects. Okay, here we go. Any two lines, any two straight lines that cross, they create four angles. And these angles have a special relationship, meaning that this and its opposite, let's say this was looks like an obtuse angle, let's say this was 126, guess what? This is also 126. Right? Now, notice that this is a straight line, right? And in any straight line, what's the angle? It's 180. So if I were to forget the bottom part and just focus on this, knowing that this is 126, I know that this guy here would be 180 minus 126, which would give us 54. So now that I find that this is 54, I know its opposite on the other side. It's also 54. So little relationships that you're going to have to understand in order to help you set up the equation. So let's look at the problems that we have to do, and hopefully that gives you a better picture. So not that, here on the back. So name two acute angles, and acute means less than 90, and they're supposed to be vertical. So meaning, as a result of this, right, two straight lines that crisscross, right, created these four angles, and name me two that are vertical. Two that are acute and vertical. So let's find out two lines that cross. Well, here's one line, and here's another one. So try to ignore everything else. So if you had those, less than 90, this one definitely looks more than 90, so that's not it. This angle right here looks like it's less than 90. Okay, so that would be the angle, and obviously it's opposite on the other side, that one, because they measure the same. So two acute angles created by two vertical, two lines that intersect. So names, well, remember, this angle is going to be called F, angle F, and then the vertex K, and then the other line G. This angle is going to be called E, vertex K, and the other line H. So these would be the answer for number one. Two obtuse vertical angles. Well, in this case, that would be just the opposite. Obtuse greater than 90. And if these two are acute, right, these two are the acute, well, these two are going to be the obtuse. Right, so this angle here, change colors, would be angle EKF, and this angle at the bottom would be HKG. A linear pair, two angles that add up to 180, right here. So let me give you the straight line first. So any straight line, and then in this line, this red line here, there are two angles, this angle and this angle. Okay, they're different angles. So this angle plus, so angle EKH plus angle, this one right here, EKF, equal to 180, and they're a linear pair. Okay. Two acute adjacent, right? Two angles that are less than 90. Well, right here. I mean, for sure, this little angle here, this one right here, is less than 90, and then this also looks like that's one less than 90. So let me name those two. First little one is GKJ angle, and the other one is angle HKJ. Okay. Complementary to FKG. Well, FKG, if they're saying it's complement somewhat, even though they didn't tell us that this is 90, well, I'm gonna assume that this is a 90-degree angle. So I'm just gonna put the symbol. So we know that this angle right here, right, formed by this line and this line, form a 90-degree angle. So what's the complementary to FKJ? So first of all, who is FKJ? FKJ is FKG. Sorry, take that back. Okay, so they're talking about this angle here, FKG. So that, I mean, that I thought it was 90, but it's not. So they're saying complementary to this angle. So the only one, so this angle here, angle FKG plus one angle that we don't know equals 90 degrees. So which angle would that be? Well, it has to be this one, right? So that you can see makes a 90-degree angle, right? These two angles, this one and this one. So the complementary angle to that one would be angle GKJ. Okay. Name an angle supplementary to FKG. So hang on a second. FKG. This is the angle that they're talking about. FKG. Supplementary. Right? Supplementary means this angle plus another angle equals 180. And obviously, if you think about a straight line, this is your straight line right here. Right? That's your straight line. So the supplementary angle to this one, to the blue one, would be this one, and I'll do it in green right here. Would be this angle. So the blue angle plus the green angle would give you 180, and the green one is angle EKF. Okay. Yeah, a little messy. Apologies. Bottom. Question 7. So question 7 is saying that, hey, here's a straight line, and we know that in a straight line the angle is 180, so that's 180. They cut it into two parts, and they said that this angle 2 is equal to, no, just right, they said that that is 57 degrees. Well, if it's a straight line, the angle is 180, so we know that, I'll put question mark. Question mark plus 57 equals 180. How do we find a question mark? Subtract 180 minus 57, and we get 23. So this green one, angle 1, would be 23 degrees. Here, it's vertical lines, right? So, vertical angle, sorry. Angle 1, they're telling you that this is 38, and what do we know? What's the characteristic here? Well, opposite angles, this angle and the one right across it, the opposite one, measure the same. So that's also 38 degrees. All right, next one. This is a straight line. Think about it for a second. This is a straight line. The whole thing is 180, right? Straight line, you have 180 degrees. But they're telling you right now, very kindly, this is 90 degrees. So if the whole thing is 90, if the whole thing is 180 and this is 90, this other side here, made by angle 5 and 6, should be 90 degrees. But they're giving us that angle 5 is 22, so how much is angle 6? Well, angle 6 is going to be 90 minus 22, which is going to be 68. Okay. Angle 1 is 65, right? And we know that when we have two lines crisscrossing, intersecting like that, opposite angles measure the same. So angle 2 is also 65. 11, this whole thing is 180 degrees. They're telling us that 67 is angle 2. And angle 1 will be 180 minus 67, which is going to give us 113. Here, we know this is 9 degrees. It clearly tells us right here. We know the whole thing, this whole thing is 180, but if we know that the left, this angle here is 90, we know 3 and 4, so we know that angle 3 plus angle 4 is 90, right? Because that's the other side. But they're telling us that angle 3 is 38. So 38 is angle 3, so 38 plus something equals 90. And what would that be? 52. So angle 4 will be 52 degrees because 52 plus 38 is 90. All right, now, I don't know if that's hard. I don't know. So I think some of you thought that 7 to 12 is harder than what's coming up next. Well, let's do 13. 13 says that angle 13, and let me write, angle 13 is represented by the expression 4x plus 11. Angle 14 currently is represented by the expression 3x plus 1. Now, what do I know about these two angles? Well, I know they're in a straight line. I know this whole thing is 180, and it was cut into two angles called angle 13 and 14. But why do I know about them two together? Well, I know that them two together equals 180. So I can say 4x plus 11 plus 3x plus 1 equals 180. 4x plus 3x is 7x. 11 plus 1 is 12, right? And then we're going to do minus 12, minus 12. 7x equals 168. I'm going to divide that by 7, divide that by 7. And I have no idea what that is. 168 divided by 7, it's 24. So x is 24, not the angle, just x. So now let me go back here. Right, so let me make this a little bit. When I go back here, right, so they said that angle 13 is 4x plus 11. So let me replace the x with 24. So it's 4 times 24 plus 11. And if you do that, 4 times 24 plus 11, you get 107. So angle 13 equals 107. Angle 14, which is on this side, so it's 3x plus 1. So we know what x is, so it's 3 times 24 plus 1. 3 times 24 plus 1 is 73. So angle 14 is 73. Now notice that when I add 73 to 107, I get 180, which is what this was to begin with. 14, they're calling angle 2 4x minus 26. They're calling 3x plus 4. Just 1 second, please. So now we call these vertical angles, right? They were created by two lines that crisscross or intersect, right? And what do we know about these angles? Well, I know that angle 2, whatever angle 2 is, it has the same value as angle 3. Okay? How does that help me with setting up the equation? Well, we know they're equal to each other, so that's how we're going to set up our equation. So we're going to say angle 2, which is currently 4x minus 26, is the same as angle 3, which is called 3x plus 4. Now I get to solve. There's variables on both sides, so let's get rid of the 3, minus 3x on both sides. That's going to be x minus 26 equals, this goes away, plus 4, plus 26 on both sides, x equals 30. So x equals 30. Again, that's not the value of the angle, it's the value of the variable. So let me go back to angle 2, which is 4x minus 26. So instead of x, I'm going to switch it with 30. So 4 times 30 minus 26. 4 times 30 is 120. And 120 minus 26 is going to give us 94. So angle 2 is 94 degrees, which should be the same as the angle 3. So let me just verify that. So again, here's x equals 30. So replace the x as 30. 3 times 30 plus 4. 3 times 30 is 90, and plus 4 is 94. I'll circle that and circle that. So angle 2 is worth 94 degrees and angle 3 is worth 94 degrees, which we already knew that they should be the same, right? Because they are vertical angles. Okay. 15. Okay, so first, what's the relationship between angle 1 and angle 2? Well, this is a straight line. And remember, that creates an 180 degrees right there. And 180 degrees were cut up into two different angles called angle 1 and angle 2. So I know that angle 1, represented by x plus 10, plus angle 2, represented by 3x plus 18, that equals to 180. Now it's just a matter of solving the equation. X and 3x, 4x, 10 and 18 is 28, equals 180. That becomes a two-step equation, minus 28, minus 28. 4x equals 152. Divide both sides by 4, and x equals 38. And again, that is not the value of the angle, it's the value of the variable. Go back here for angle 1. Angle 1 says x plus 10, so instead of x, I'm going to replace it with 38. So we're going to get 38 plus 10. So angle 1 is 48 degrees. Angle 2, to find angle 2, you're going to do 3 times 38 plus 18. 3 times 38 plus 18, and that's going to give you 132. 132 degrees. So double check. These two added up should be 180, so just add 48 plus 132. Does it give you 180? It does, so you know these two are correct. Right? So you're using equations which you've been doing for a long, long time now, so I shouldn't even be concerned about that. Now it's just understanding what kind of relationship the two angles that are given to you, the angles that are given to you, and then using that information to set up your equation properly. So again, vertical angles here, created by two intersecting lines. So we know that when that happens, this angle here is the same as this angle, and this angle here, and I'll use two lines, is the same as this side. We know that for a fact. So knowing that, how do I set up? This says that angle 6 is exactly the same, is congruent as to angle 7. How do I use that to set this equation? Well, angle 6, which is 7x minus 24, is the same as angle 7, which is 5x plus 14. We have variables on both sides. Let's get rid of the 5x, so minus 5x on this side, minus 5x on that side. So 5x goes away, 14 is left over, and here I have 2x minus 24. We're going to do plus 24 on both sides. 24 goes away, 2x equals 38. Divide by 2, divide by 2, x equals 19. Again, not the value of the angle, but the value of the variable. So now let me take that 19, plug it here, change it for x, and plug it here. All right, so let's do angle 6. So angle 6 is 7 times 19 minus 24, and that's going to give us 7 times 19 minus 24, that's going to give us 109. So this angle 6 is 109, which means angle 7 is 109, but I just want to check. So 5x, right, so I'm going to use this expression now. 5x plus 14, I'm going to go 5 times 19 plus 14. 5 times 19 plus 14 equals, look at that, 109. Right, like I said, we knew that they should be equal, and we just confirmed it. So angle 6 is 109, angle 7 is 109. 17. What in the world? Okay, so we're talking about angle 4 and angle 5. Okay, so let me just take that drawing over here. Right, they're saying this is 90 degrees. Right, there's a symbol there. See that square? It says 90. That means that this angle is 90 degrees. Now, aren't these two lines that intersect, right? Two lines like this. So they create vertical angles. So if this is 90, the opposite, the angle on the other side, guess what? This is also 90. And guess what? If that's 90 and this is 90, it means, right, if you think about a straight line, right, let me erase this for a second. I'll put it right back. So if I told you that this is 90 and I asked you for this side here, what would that be? Well, the whole thing is 180. So 180 minus 90 equals 90. So that's 90. Right? So basically, this ends up being 90, and this ends up being 90. Great. So how do we use that information? So we know now that these two, angle 4 and 5, so angle 4 plus angle 5 equals 90 degrees. That's how I'm going to set up my equation. So angle 4 is 2x minus 5 plus angle 5, which is 4x minus 13. Somebody made a comment today that I should put parentheses here. Yes, you're absolutely correct. But because it's addition, okay, look what happens. You're supposed to be parentheses, and now the next step would be to do the distributing property, right? There's an invisible 1 here. So let's do that. 2x minus 5, and if you do the distributive property, plus 1, positive 1 times positive 4x is 4x. Positive 1 times negative 13 is negative 13. Notice that these two guys here, these two terms inside the parentheses came out. The parentheses is exactly the same. So when it's addition, right, you don't really have to put the parentheses because they come out the same. But if that was subtraction, you have to. Okay, so 2x minus 5 plus 4x minus 13 equals 90. Let's combine like terms. We can combine these two. We get 6x. Negative 5 and negative 13 is negative 18 equals 90. Now it's a two-step equation. Plus 18 plus 18. 6x equals 108. We're going to divide both sides by 6. And 108 divided by 6 is 18. So x is 18. Knowing that, let's go back here. Right? Let me erase this. Let's go back to angle 4. Angle 4 is 2x minus 5. Right? Angle 4. And we replaced it x with 18, so we got 2 times 18 minus 5. 2 times 18 is 36. 36 minus 5, 31. So angle 4 is 31. Angle 5 is represented by the expression 4x minus 13. We're going to do 4 times 18 minus 13. And 4 times 18 minus 13 is 59. And just for you to confirm, if you take 59 and 31, right? If you take 59, 31 plus 59, you get 90? Yes, you do. And that's what they are supposed to equal, right? 4 and 5 is supposed to equal 90. Perfect. 18. Okay. 7 and 8 are complementary. Right. So right off the bat, 7 and 8 are complementary, which means 7, angle 7 plus angle 8 equals 90. That's basically what they're saying. They're complementary. They're telling you that angle 7 plus angle 8. So we know these two, right? There's a 90 degree angle there. So we know that angle 7 plus 8 is 9. Okay. Angle 5 is the same as angle 8. And angle 6. So again, right, so let me go back. So if this is 90 degrees, so again, think about this. Let me take that. Let me take all that stuff out. So if I told you this was 90 degrees, right? How much would be this side? Well, that side would also be 90 degrees, right? Because it's a straight line. And a straight line forms 180 degrees, right? So in here, they're telling us that 7 and 8 are complementary, which means their sum equals 90. So we know, and I'll draw it again, we know right here, this angle is 90 degrees. Okay? So if that's 90, the other side also is 90. Okay? So let's start doing this. So 5 and 8 are complementary. We know 7 plus 8 is 90. Angle 5 is the same as angle 8. Right? So this is another, I'll change colors. That's 90 degrees on the right side. And guess what? It's 90 degrees on the left side. And angle 6 here, this buddy here, is 29 degrees. So let's focus on the left side. On the left side, we have something like this. Right? We already established that it's 90 degrees. Somebody came and cut the 90 degree angle into two parts, and they said, hey, this is 29. What is this guy right here? Well, if they're supposed to equal 90, so we just do 90 minus 29, and you get that this guy is 61. Okay. Now, let's use that information. This is angle 5. Angle 5 is 61 degrees. And they're telling you that angle 5 and angle 8 are congruent. So I can go on the other side and say, hey, you're also 61. And angle 7 is going to be 29 because angle 8 plus angle 7 is supposed to give you 90 degrees. So these two should add up to 90. That's it.